I'm Oscar Romero, and this talk is on the paper A Long-Term Evaluation of an Adaptive Interface Design for Mobile Transit Information. In this study, we explore the long-term implications of an adaptive user interface in a mobile transit application called Tiramisu that reduce the amount of bus route filter selection, scrolling, reading of screens, and other navigation. A random forest machine learning model was constructed to predict desired routes and direction. We use an A/B study to assess the long-term impact of the adaptation and compare participants into conditions. In the adaptive condition, the user interface was adapted to participant needs by filtering bus routes and trip direction. In the non-adaptive condition, the system made no attempt to automatically filter bus routes or trip direction. We collected data from 16 participants during an 18-month window. We proposed 4 hypotheses. First, participants in the adaptive condition will select fewer filters and make fewer navigation actions than participants in the non-adaptive condition. Second, participants in the adaptive condition will select fewer filters and make fewer navigation actions, even when the machine learning model generates incorrect route predictions. Third, participants who use the screen reader in the adaptive condition will select fewer filters and make fewer navigation actions than sighted participants in the non-adaptive condition. And finally, participants in the non-adaptive condition will abandon the app at a higher rate than participants in the adaptive condition. After conducting a statistical analysis, we conclude that hypothesis H1 and H1.2 were confirmed. However, hypothesis H1.1 was rejected because, over time, participants in the adaptive condition selected more filters and made more navigation actions when the machine learning model performed badly. Hypothesis H2 was also rejected because there was no significant different abandonment rate between participants in both conditions. One reason for both groups having a similar abandonment rate may be due to a noise factor where people left the city or transit, which manifested in the data as an abandonment. For example, a job change, a degree completion, etc. One design recommendation that we take from this study is that the HCI community needs to think better about the dimensionality of the problem when using machine learning to avoid adverse effects of adaptation, such as user frustration and app abandonment. For instance, our machine learning model uses simple features, but modeling travel patterns and human behavior can be much more complex, encompassing changes in lifestyle and routines, occasional changes in trip plans, changes in social circles, multi-scale time sensitivity, and more. We anticipate that adaptive user interface that reduce effort can lower cognitive and interaction load, which is especially important for people with vision impairment and other kinds of disabilities, such as cognitive or dexterity disabilities. We provide empirical evidence that a well-performing adaptive interface leads to reduced interaction effort, while poor performance may lead to more interaction effort than no adaptation. The contents of this paper were developed under grants from the National Institute of Disability, Independent Living, and Rehabilitation Research. Thank you.